Today we will see the numericals on belt conveyor. So problem statement is a flat horizontal belt conveyor is to be used for transporting the material with a mass density of 3 tons per meter cube. The belt is 1 meter wide and has a speed of 2 meter per second. Determine the capacity of the conveyor if surcharge angle is 20 degree. So this is the problem statement. Our aim is to find out the capacity of the conveyor. Then given data, so the density of the material is given, mass density of the material, that is a 3 tons per meter cube. So the density of the material will be equal to 3000 kg per meter cube. Then speed of the conveyor is 2 meter per second. V is equal to 2 meter per second. Then belt width is given as a 1 meter. So B is equal to 1 meter. Then surcharge factor for the surcharge angle 20 degree is considered as a C is equal to 0.07. Therefore, we have a formula to determine the volumetric capacity of the conveyor. So the volumetric capacity of the conveyor is determined by using the formula Q is equal to CB square V. So this is the formula to calculate the volumetric capacity of the flat belt conveyor. So C is the surcharge factor, B is the effective belt width, V is the velocity of the belt conveyor, and Q is the volumetric capacity of the conveyor. Therefore, putting the value of B, that is the effective belt width, is a 0.9 B minus 0.05 bracket square. So C into 0.9 B minus 0.05 square into V. Therefore, putting the value of C, then the value of capital B, that is a belt width, and velocity of the belt conveyor. In this way, we can get the volumetric capacity of the belt conveyor 0.10115 meter cube per second. So that will be Q is equal to, we are converting into the meter cube per hour. So 3600 multiplied with the volumetric capacity. So the final volumetric capacity of the conveyor is 364.14 meter cube per hour. Next, we are going to calculate the mass capacity of the conveyor. So the mass capacity of the conveyor is given as M is equal to rho into Q. That is nothing but a density of the material into volumetric capacity of the material. So 3000 is the density of the mass density of the material, and 364.14 meter cube per hour is the volumetric capacity of the conveyor. So we'll get the mass capacity of the conveyor 1092.4 into 10 raised to 3 kg per hour. We are going to convert this into the tons per hour. Therefore, mass capacity of the conveyor is equal to 1092.4 tons per hour. So in this way, we calculate the mass capacity of the conveyor by using the volumetric capacity of the conveyor and mass density of the conveyor or mass density of the material. Now we will see one more example on the same. Horizontal belt conveyor is used for transporting the material having density 11,772 Newton per meter cube. Then belt width given as a 0.7 meter and belt speed given as a 1750 mm per second. So we have to determine the capacity of the conveyor, that is nothing but the mass capacity of the conveyor, and surcharge for the belt is given as a 0.2. So this is the problem statement for our problem. So here given that the density 11,772, then if belt width is a 0.7 meter, V is equal to 1.75 meter per second, and C is equal to 0.2. So the conversion of the rho G into the rho, so we have to divide it by the 9.81 value. Therefore, density of the material will be equal to 1200 kg per meter cube. Then volumetric capacity of the material is calculated by using the formula CB square V. So this is the C is the surcharge factor, then B is the effective belt width, and V is the uh, speed of the belt conveyor. So just putting the values of P in the form of belt width. So you'll get the final value for the volumetric capacity 0.117 meter cube per second. So we are converting it into the meter cube per hour. So the volumetric capacity of the conveyor will be equal to 423.86 meter cube per hour. Next is the mass capacity of the material. Mass capacity of the material is calculated by using the formula M is equal to rho into Q. Therefore, rho is 1200 and our volumetric capacity is 423.86. Therefore, the mass capacity of the conveyor is 508.637 into 10 raised to 3 kg per hour. So we are going to divide by 1000 so that kg per hour can be converted into the tons per hour. Therefore, the final mass capacity of the conveyor for the material or flat belt conveyor is M is equal to 508.637 tons per hour. So in this way, we can determine the volumetric capacity of the belt conveyor as well as mass capacity of the belt conveyor. Now we will see one more example on horizontal belt conveyor. So here it is a problem statement. A horizontal belt conveyor is used for transporting the bulk material having mass density of 1200 kg per meter cube. The surcharge factor C for the flat belt is 0.1, while the belt width is 650 mm. If the belt speed is 175 meter per second, determine the capacity of the conveyor. So here our aim is to find out the capacity of the conveyor for the given conditions. So the what are the different given parameters are there? So first is the mass density, that is a rho is given 1200 kg per meter cube. Surcharge factor C is given as a 0.1 and belt speed V is given as a 1.75 meter per second. So simply we write the again given parameter rho density of the material 1200 kg per meter cube. Surcharge factor C is equal to 0.1. Then belt width is given as a 650 mm. So B is equal to 0.65 meter. Then belt speed is 1.75 meter per second. Therefore, volumetric capacity of the conveyor is given as Q is equal to CB square V. Therefore, putting the value of effective belt width as a 0.9 B minus 0.05. Therefore, we will have the C Q is equal to C into 0.9 B minus 0.05 square into V. Putting the value of surcharge factor, then given belt width and belt speed in the formula of volumetric capacity, we will get the volumetric capacity equal to 0.05009 meter cube per second. Now we are converting volumetric capacity into meter cube per hour. So multiply volumetric capacity by 3600. Therefore, the final volumetric capacity of the belt conveyor is 180.32 meter cube per hour. Now our aim is to find out the mass capacity of the conveyor. So the mass capacity of the conveyor is calculated by using the formula M is equal to rho Q kg per hour. So the rho density is 1200 and volumetric capacity is 180.32. Therefore, the mass capacity of the belt conveyor is 216.386 ton per hours. So in this way, we can calculate the volumetric capacity and mass capacity of the flat belt conveyor system.